Okay, today we're talking about 4.8, which is going to be a collection of word problems. Some are a little bit of review, so if you're able to do them, you can kind of fast through the video. If you have to pause at any time, if it's going too fast, please do so. So by the end of today's lesson, you should be able to use right triangle trigonometry to solve application problems. So you are standing 100 feet from the base of a platform, which people are bungee jumping. The angle of elevation from your position to the top of the platform for which they jump is 51 degrees. From what height are the people jumping? So I essentially have this platform, and people are jumping off of the platform. Okay? So this is essentially going to create a right triangle where I am 100 feet from the base. So since it had that keyword base, that would be the bottom here. It said angle of elevation was 51 degrees, so this bottom angle looking up would be 51 degrees. So we want to find the height from what people are jumping. So you have to look at what trig function you have. You have the opposite and the adjacent, so that's tangent. So I'm going to say tangent 51 degrees equals x over 100. We can multiply 100 by both sides. So I'm going to get x equals 100 times tangent of 51 degrees. So we're going to put that in the calculator, and hopefully you're in degree mode. So you should get x is approximately 123.5 feet. So that is the height from which people are bungee jumping. Okay? If you look at this next one, it says angle of depression. So a global positioning system satellite orbits 12,500 miles above the Earth's surface, and we're looking at this figure. Find the angle of depression from the satellite to the horizon. Assume the radius of the Earth is 4,000 miles. So if I look at this picture, I know that the radius, so this side of the triangle, is 4,000 miles. And then I know from the Earth to the satellite is 12,500 miles. So we're going to need another part of the triangle. So hopefully you're thinking, let's figure out what this part would be. Well, that essentially is another radius. So that would be 4,000 miles. So the whole hypotenuse of this right triangle would be those combined, so that's 16,500 miles. Okay? All right, I am going to kind of redraw this picture so we can kind of get a little bit better of visual. All right, so I know the hypotenuse is 16,500 miles, and I know this side of the triangle is 4,000. We want to find this angle of depression here. Okay. Before we can do that, we're going to have to find the angle adjacent to it that is inside the triangle. Because I have two sides of this right triangle, I can find that missing angle. And then if you look, these two angles combined would be 90 degrees. Because here I have a 90-degree angle, and then that means these two angles combined would be 90. So I'm going to find that interior angle first. So looking from that angle, I have the opposite and hypotenuse, so that's going to be sine. So I'm going to say sine of x equals 4,000 over 16,500. And now I can take the inverse sine of both sides.